In this lesson, you will learn how to add and subtract radicals. Let's take a look at some examples to better explain this concept. In this problem, we have 3 radical 7 minus 5 radical 7 plus 8 radical 7. Now, in order to be able to add these, they need to be like terms. To determine if radicals are like terms, you look at the number under the radical sign. As long as they are the same numbers, they are considered like terms, which means these can all be combined together. Now, when you combine them together, the number under the radical stays the same, similar to when you're adding fractions like 3/4 plus 2/4. You keep the denominator the same, and you just simply add the numerator. Well, in the same way, when we combine these, we're going to keep the radical the same because that's what's telling us that we can combine them. And then we're going to take the numbers in front of the radicals, so 3, -5, and 8, and that is what we will add. So we have 3 minus 5 plus 8. So when you calculate that, you would get -2 plus 8, which is 6. And the 6 is what goes in front of the radical. So we can say we have 3 radical 7s minus 5 radical 7s plus 8 more radical 7s, which gives us a total of 6 radical 7. Let's take a look at the next problem. Now notice in this next problem that the numbers under the radicals are not the same, which means at this point they are not like terms. Now what you must do at this point is take a look at both numbers and decide if either one of them can be broken down further using a factor tree. So let's start with the 27. Using a factor tree, we would break it down into 3 times 9, circling our prime numbers, and then the 9 can be further broken down into 3 times 3. So we have 3 times 3 times 3 as our prime factors of 27. We will then underline any pairs of numbers and multiply them together. And we'll put a radical sign around that, and then anything not part of a pair also will get its own radical. So in other words, radical 27 breaks down into radical 9, radical 3. From here, since radical 9 is a perfect square, we will take its square root and get a 3, and then drop down the radical 3. So radical 27 has now changed into 3 radical 3. Now we're going to drop down the minus 5 radical 3 because we can see that the radicals now match, so we now have like terms, and so we can now combine them. So again, we're going to keep the number under the radical the same when we combine them. What we're actually adding would be the numbers or in front of the radicals, which would be 3 and then on -5 or -5. So 3 minus 5 is -2. So our answer is -2 radical 3. Let's take a look at an additional example. Here we have 3 radicals, radical 20 minus 2 radical 24 plus radical 45. Now you can see that none of the numbers under the radicals match. So at this point, we have no like terms. Now let's go down to the bottom here, and let's go ahead and we're going to factor the 20, and then we'll factor the 24, and then we'll factor the 45. So 20 breaks down into 2 and 10, and then 10 breaks down into 2 and 5. So we have 2, 2, and 5. If you underline the pair, we will end up with square root of 4 and square root of 5. So we'll bring that back up over here under the radical 20. And this will then break down further by taking the square root of 4 into 2 radical 5. Now for the next one, which is -2 radical 24, make sure you drop down that -2. And what we're breaking down is simply the 24. So we would have 2 and 12, 2 and 6, and 2 and 3, which gives us 2 times 2 times 2 times 3. Underline your pairs, which would just be the 2, and multiply them to give us our first radical. And then anything that's not a pair, in this case, multiply them together to get radical 6. So radical 24 breaks down into radical 4 and radical 6. Then we'll take the square root of 4 and get 2, and drop down the square root of 6. So now we have 2 radical 5 minus, and we can multiply our outside numbers, which would be 4, and then radical 6. So from here, let's now break down the 45. 45 breaks down into 5 and 9, and 3 and 3. So we have 3 times 3 times 5. Underlining our pairs, we will multiply those to get radical 9, and the remaining radical will be radical 5. So radical 45 breaks down into radical 9, radical 5. The square root of 9 is 3, so we now have 3 radical 5. So let me drop that down. So we have plus 3 radical 5. Now, how many of these radicals are like terms? Hopefully you can see only the first and the last have the matching numbers under the radical symbols. So the one in the middle, the negative 4 radical 6, will not be combined with anything at this point. We're only going to combine 2 radical 5 with positive 3 radical 5. Now, the negative sign or the minus sign goes with the 4, so it has nothing to do with combining the 2 and the 3. We're going to be using the sign in front of the 3, so we will be adding the 2 and the 3. So 2 radical 5 plus 3 radical 5 is 6 radical 5, and we will drop down the minus 4 radical 6. And at this point, this is as far as we can simplify this problem. Let's take a look at our last example. In this example, we now have variables. So let's take a look at how we'd approach this problem, pretty similar to the last one. We're going to look and see if any numbers under the radicals match, which they don't. So now what we need to do is we need to break down the 8 and the 18, but the 2 cannot be broken down any further. Now you may notice that both of these have x squared. So if you want, you could take the square root of both of those at the beginning or save it to the end. I will go ahead and take their square root at the beginning. Now recall that to take the square root of a variable, you're just dividing its exponent by 2. And that allows it to move outside the radical. So 2 divided by 2 is 1. So I now have an x outside the radical with the 2, and it's no longer inside. I can simply drop down our second term. Then in our third term, like the first, once I divide the exponent by 2, I will bring the x to the outside, so I only have the 2 remaining under the radical. Now I can start to break down 2 of the radicals, radical 8 and radical 18. Radical 8 breaks down into 2 and 4, which further breaks down into 2 and 2. So we've got radical 4, radical 2. So let's go ahead and write that. So we have 2x, and then the radical 8 breaks down into radical 4, radical 2. And this further breaks down, since the square root of 4 is 2, into 2 radical 2. Then from here, we can multiply the outside numbers, so we get 4x radical 2 for our first term. Let's now move to the radical 18 and break that down. We get 2 and 9 and 3 and 3. So we get 2 times 3 times 3, which would be radical 2, radical 9. Now let's transfer that up here, drop down the 3x, and then we have radical 2, radical 9. We could go ahead and drop down the third term because we cannot break down the 2. From here, we can simplify radical 9 and bring that to the outside. So we'd have 3x times, and this becomes a 3, then radical 2, and then we'll drop down again the third term. Then we must finish the middle term. We will multiply the numbers outside the radical to get 9x radical 2, and then we can drop down the minus 4x radical 2. Now, if you look at this last row, we have 4x radical 2, plus 9x radical 2 minus 4x radical 2. Now, they all have radical 2's, and because all of the numbers in front of the radicals have an x, we can add 4x plus 9x and then subtract 4x. So 4 plus 9 is 13x, and then 13 minus 4x is 9x. So our final answer would be 9x in front of the radical, and then we just drop down the radical 2. And that completes the lesson on adding and subtracting radicals.